Good day, everyone. Today, we will be discussing games under Chapter 4, Mathematics and Decision Sciences. Game theory is the study of strategic decision making where situations are called games and the participants are called players. It deals with problems in which a player's strategy depends on what other players do. There are three components of a game. First are players. These are the decision makers. The goal is to get the best game that will result in the best decision. The second is actions. These are all possible moves of each player. And lastly, the payoffs. These are the outcomes in the form of gains of losses of the players depending on their aggregate moves. One famous game is the Prisoner's Dilemma, which states the following scenario. Two suspected felons are caught by the police and interrogated in separate rooms. They were told that if you both confess, you will each go to jail for 10 years. If only one of you confesses, he gets only 1 year and the other gets 25 years. And if neither of you confess, you each get 3 years in jail. This is an example of an extensive form of the prisoner's dilemma. The order of moves is represented from the left to right of the tree. The leftmost node represents the first move of player 1, which is to confess or do not confess. The two nodes to the right of it are called subgames. Each represents player 2's possible reaction to the first move made by player 1. The rounded rectangle indicates that when the second player makes his or her decision, he or she does not know the decision of the first player. The four nodes in the right column are terminal nodes. They represent all four possible payoffs to this particular game. On the other hand, the normal form of prisoner's dilemma looks like this. Here, the payoffs are in the cells. This payoff table indicates that if the first prisoner confesses, the other will also prefer to confess. If the first prisoner does not confess, again, the second prisoner will prefer to confess. The goal of a game is not winning, but identifying one's optimal strategy. Whether that means ending up ahead of another player is of no consequence. The only concern is whether the optimal strategy has been used. Moving on to the classification of games, we have simultaneous and sequential games. A simultaneous game is when each player has only one move. All these moves by the various players are done simultaneously. For example, rock, paper, scissors. Both players make a decision simultaneously without knowing what the opponent's move is beforehand. On the other hand, a sequential game is when no two players move at the same time, and players may have to move several times. For example, is chess and tic-tac-toe. Next is randomness. Games may contain some random events which can influence the outcome of the game. For example, the injury of a player in basketball. When one player gets injured, that player cannot play the game, which can affect the outcome of the game, especially when that player always gets point for their team. Next, we have perfect information and imperfect information. The game is perfect information if each player, when making a decision, is perfectly informed of the actions done. For example, is tic-tac-toe and chess. All moves are known to both players, while both players may not know or not completely know the payoffs of the game. On the other hand, the game is imperfect when all players know the structure of the game, but don't know the possible moves and possible payoffs of other players. For example, is poker and battleship. Next is complete and incomplete information. We call it complete information if the structure of the game and the payoffs of the players are commonly known to all players. For example, is casino. Each player has all the knowledge about others' characteristics, strategy spaces, payoff function, and etc., which makes this a complete information game. On the other hand, it shows incomplete information because the players are unaware of the payoff of the game and are completely uninformed about the structure of the game. For example, is competitions between two companies. For a zero-sum game, for every possible outcome of this type of game, the sum of the payoffs of all players equals 0. A player can only win or have a possible payoff if some other loses or has a negative payoff. Real-world games are rarely zero-sum. For cooperative and non-cooperative games, a game is cooperative when players can form coalitions. Cooperative game theory assumes that a group of players called coalitions are the primary units of decision-making and may enforce cooperative behavior. Thus, a game is non-cooperative when players cannot form alliances when players are competing against each other to gain the best payoff. This ends our discussion on games under Chapter 4. Thank you so much for listening and see you on our other tutorials.